Today, in preparation for section 5.2, we're going to be working with exponents. So we have several different rules for exponents, and we're going to practice each of them today. The first rule being the zero exponent. Anything raised to the zero power equals 1. When you think about something like x squared, that means x times x. So I have two x's being multiplied together. If instead I have x to the 0, that tells me I don't have any x's, so I always have a hidden 1. So that's why we say anything to the 0 power is 1. There is none of that term, and the only term that is in there is 1. The next one is our negative exponent rule. So anytime that you see a negative a in our exponent, we're looking at 1 over x to the a then. We also have a product rule, so if we are multiplying two things that have the same base, notice it's x to the a times x to the b, well that becomes x to the a plus b. We also have a quotient rule where if we have x to the a over x to the b, then we're going to just take their difference, x to the a minus b. So we just subtract the exponents there. Lastly, we have a power rule, so if I have some power of x being raised to another power, we multiply those powers. And then we have a power of a product rule, where when you have a product, x times y, being raised to an exponent a, you distribute that exponent to each of the factors in the product. So it becomes x to the a, y to the a. So let's see this in practice. Our first example is 7x to the 0. So the 7 doesn't have any exponents on it. It doesn't change at all. The 7 stays. And x to the 0 becomes 1. So this is 7 times 1, which is just 7. Now we have 5x to the minus 2. This is our negative exponent rule. And so the x must go to the denominator. So we get 5 left alone divided by x squared. So that minus 2 in the exponent just means put the x in a denominator. This still has power 2. Now with part C, notice I have x to the 6 times x to the minus 2. Those two are the same base, so I can just add their exponents. And I get x to the 6 plus negative 2, which of course is x to the 4. With our next example, we have a quotient rule. We have division here. So we have 30x to the 5 over 6x squared. Now, the 30 over 6 can be broken off, and 30 over 6 reduces to 5. And then we have x to the 5 over x squared, and those two have the same base, so we can take x to the 5 minus 2. And so that becomes 5x cubed. Now in this next one, we have our power rule, where we have 2x to the negative 3 quantity squared. Now there's a little bit extra kind of work we'll have to do with that x to the minus 3, but the first step here is to handle the parentheses. See, it's 2x to the minus 3 squared, so the 2 and the x to the minus 3 are both being squared. So this is 2 squared times x to the minus 3 times 2. So here we have our square being distributed to both our factors, and then also when we already have an exponent, like x to the minus 3, we multiply it with the 2. So this becomes 4, since 2 squared is 4, x to the minus 6. But we want to get rid of that negative exponent, and becomes 4 over x to the 6. So the minus is gone in the exponent when we move it to the denominator, notice. All right, lastly, we have a similar idea. We have our negative 3a squared times b, all raised to the third. So we do have some different variables here, but it's just to make you practice working with different letters. Our base is a in one of the factors, and our base is b in a different factor. So you'll see those are two that can't be combined any further. We want to take that cube in the top in our exponent, and we want to distribute it to each of our factors. This becomes minus 3 cubed, a squared cubed, b cubed. So minus 3 cubed is minus 27. A squared cubed is a to the 6th, and b cubed is just b to the 3rd cubed. Now the a and b are different bases. They cannot be combined at all, so that's as simple as this one can go. So there are a ton of practice problems here working on reducing different exponents. So I highly recommend you give it a go and reach out if you have any questions.